Welcome everyone. Today we are taking up another problem from JEE Advanced 2025 paper 2 related to geometric optics. And interestingly, this problem is a combination of two problems from HC Verma book. Okay, so let's look into the problem. There are two spherical converging mirrors placed at a distance of d having same focal length f and f, having small apertures, and right at the center we have placed a glass slab of thickness t with an object embedded within this glass slab, and the refractive index of the glass slab is n naught. Okay, fine. So let's think about it. What if this glass slab was not present? Could we get the image and the object at the same position? Definitely. What it is, if this object location from any of the two mirrors are behaving as one center of curvature. Second, it could be a focal length of one mirror or the other mirror. How? It actually, the incident ray falls on one of the mirrors and it goes straight. That means the image will be at infinity. So that image at infinity becomes the object of another mirror, and it actually points the reflected ray at the position where the object is. So there are two differences. Okay. Now the only problem is when having a glass slab, what is the difference? Whenever an object is inside a denser medium, we know that there is an apparent shift in the depth. Okay, so that apparent shift is what we need to calculate. Once we know the apparent shift, then we can actually make the object position to that particular location and make it behave as if it's the center of curvature, or is it the focal length. So let's simply calculate the apparent depth. I'll make this bigger, okay, so that I can actually draw a proper diagram. Let this be the thickness T. So this is thickness T and this is my object. Okay, I'll just simply take for one surface, the other surface follows this. So this is, I have drawn a normal. Incident ray go like this, and what will happen? Because from denser to rarer medium, it will actually go like this, and it will appear as if my object is at this location, not this. Okay, so if this was the incident angle, I can simply say this is my I. If this is my R, so this is also R. And I know that this thickness is T by 2. And I need to determine this value, X. What is the shift? So if this is X, that means this thickness, remaining part is T by 2 minus X. Okay. So let's actually write the formula. What is constant in these triangles? This is height H is constant. That means at from what position we are looking in. Okay, so if h is same, that means I can simply say h by p by 2 is equal to sin I, and also we can say h by p by 2 minus x is equal to sin r. Now you will ask, where did I get sin r? It should be tan I and tan r, right? That's correct. The only reason is because the aperture is small, that means theta is equal to sin theta equal to tan theta. So that is where I am getting. Because the aperture is small, everything is happening at a very small aperture angle. Okay, so tan I becomes sin I, tan R becomes sin R. Now I can simply divide sin I by sin R, and so this left side will become p by 2 minus x by p by 2 is equal to sin I by sin R. And what will be my sin I by sin R? Mind that this is going from denser to a rarer medium. So this will become 1 by n. Okay, so how will I get x? So from this I will get x is equal to p by 2 1 minus 1 by n. So this is one equation I got for x. Great. So if I got this value, that means what will be, so this is my new position, let's say. So if this was d by 2 and this portion, this small portion is what? This is x, right? So what will be my new position from the mirror? New position will be d by 2 minus x. And that will be equal to what? Two things. One, it could be a focal length, or, so this is one equation, and another equation is minus is equal to 2f. That means center of curvature. So let's talk about this first equation. Okay. So if this is the first equation, I know what is x is. So if I move this x in this direction, so what will be my d by 2? D by 2 will become f plus x, right? And what is the value of x? T by 2, 1 minus 1 by n. Or if I multiply the both sides by 2, so d becomes 2f plus t 1 minus 1 by n. That is considering it to be the focal length. So one solution we got. What for this second solution? So this becomes d by 2 equal to 2f plus t by 2 1 minus 1 by n naught. Multiplying again both sides by 2, so this d becomes 4f plus t 1 minus 1 by f. Simple, right? Right. Once you figure out the apparent depth, it becomes very straightforward question. The only thing is you need to think that how many sorts of positions I can have when I have combination.